You press the flush lever. The bowl clears in seconds. You walk away. But nothing has disappeared. That dirty water has only crossed the point where you can no longer see it. From there, it may travel through pipes, pumps, screens, settling tanks, microbes, laboratories, and miles of hidden infrastructure. So what actually happens after you flush the toilet? The exact journey depends on where you live. A home with a septic tank follows a different path. Some places still lack safe sewer service, but in many sewer-connected cities, your flush begins a journey toward a municipal wastewater treatment plant. First, the toilet releases stored clean water into the bowl. That rush pushes the contents through the curved trap beneath the toilet. The trap always keeps a little water inside it. That small pool blocks sewer gases from drifting back into your bathroom. Then gravity takes over. Your flush joins water from showers, sinks, washing machines, restaurants, offices, and factories. The U.S. Geological Survey calls all of this wastewater. Used water carrying human waste, food, oils, soap, chemicals, and other materials. The pipe leaving your home feeds a larger pipe beneath the street. That pipe joins an even larger sewer main. The system works like a river network in reverse. Tiny branches combine until one dirty underground river moves toward a treatment plant. Most of the route slopes downhill, but cities are not perfect ramps. When the land rises, a lift station uses pumps to raise the wastewater so gravity can carry it again. Now imagine one wet wipe entering this stream. It looks soft and harmless. But it may not break apart like toilet paper. It can twist around grease and other wipes, creating a rope-like clog inside a pipe or pump. The U.S. Environmental Protection Agency warns that even some products marked flushable can help cause sewer blockages. If a pump fails, sensors may trigger alarms and backup equipment. Crews can reroute flow or bring temporary pumps. But if the pipe is blocked or the system is overwhelmed, untreated sewage may back up or spill outside. The invisible system becomes visible very quickly. Eventually, your flush reaches the treatment plant. At a plant handling 10 million gallons daily, that flow could fill about 15 Olympic swimming pools every day. The first job is stopping large objects from destroying machinery. Wastewater passes through metal screens that catch wipes, rags, plastic, sticks, and other debris. Treatment workers find objects that should never enter a sewer: wood, rocks, even dead animals. Your toilet is connected to industrial equipment, but people often treat it like a magical trash portal. After screening, the water slows inside a grit chamber. Heavy particles such as sand, gravel, coffee grounds, and broken materials sink. Removing grit protects pumps and tanks from wear. Next comes primary treatment. The wastewater enters a large settling tank called a clarifier. The flow becomes calm. Heavy solids sink as sludge. Oils, fats, and floating material rise and are skimmed away. The U.S. Geological Survey says primary treatment can remove about 60% of suspended solids. That sounds impressive, but the water is still far from clean. Much of the pollution is dissolved or too small to settle, so the plant recruits living workers. The water enters an aeration tank, where blowers push in oxygen. Billions of bacteria and other microorganisms feed on organic waste. They turn much of it into new microbial cells, carbon dioxide, water, and simpler compounds. This is biological treatment. Plant operators keep a working community alive inside the tanks. They control oxygen, mixing, temperature, and how long the microbes stay. Think of it as a giant restaurant where the customers are microscopic and the menu is sewage. If toxic chemicals arrive, the customers can become sick or die. If too little oxygen enters, the meal slows down. The plant must keep the dining room busy without letting it collapse. The Environmental Protection Agency trains operators to watch which microorganisms grow in activated sludge. Different tank conditions favor different species. Some form clumps that settle well, others grow into long threads and make settling difficult. After aeration, the water enters another clarifier. The microbial clumps sink. Some are pumped back into the aeration tank. The extra becomes waste sludge and enters the solids treatment line. Many plants then remove nutrients such as nitrogen and phosphorus. These nutrients sound helpful because plants need them. but too much entering a river or lake can feed huge algal blooms. When the algae die and decay, they can strip oxygen from the water and harm fish. Now, the water may look clear. Clear does not always mean safe. Before release, many plants disinfect it using chlorine, ultraviolet light, ozone, or another method. Ultraviolet systems damage microorganisms so they can no longer reproduce. Chlorine kills pathogens, but leftover chlorine may need removal before the water reaches wildlife. This reveals a major trade-off. Stronger treatment protects people and ecosystems, but it uses more energy, equipment, chemicals, and money. Aeration needs large blowers running for long periods. A city must balance cleaner water against cost, energy use, and plant limits. Storms make that balance harder. In some older cities, rainwater and sewage share the same pipes. The EPA calls these combined sewer systems. During heavy rain, the flow can exceed what the pipes or plant can handle. Relief points may release a mixture of stormwater and untreated sewage into nearby water. That sounds like a design failure. In one sense, it is. But relief points can also prevent the mixture from backing up into streets and homes. The system protects one place by accepting damage somewhere else. After treatment and testing, the liquid leaves the plant as effluent. Depending on local rules and design, it may enter a river, lake, ocean, wetland, or reuse system. Some treated wastewater waters parks, cools industrial equipment, or receives extra treatment for other uses. The World Health Organization stresses that safe sanitation is not just owning a toilet. Waste must also be contained, moved, treated, and reused or disposed of without exposing people to danger. The flush is only the visible doorway into that longer chain. The solids take another path. Sludge from the clarifiers may be thickened and placed inside sealed digesters. There, bacteria break down organic material without oxygen. This can reduce odors and pathogens while producing methane-rich biogas. Some plants burn that gas for heat or electricity. After further treatment, the remaining material may become biosolids used on land, or it may be landfilled or burned. The choice depends on local rules, contamination, cost, and public acceptance. The solid part of your flush can end as fuel, soil material, ash, or buried waste. And here is the strangest twist. Wastewater is not only something cities clean, it is also information. The U.S. Centers for Disease Control and Prevention tracks signs of infectious diseases in sewage. A sample from one plant can reveal whether certain viruses are rising across a community, even before every sick person visits a doctor. Your flush can become part of a public health signal. So the bowl may look empty, but the action was never small. It activated home plumbing, a buried transport network, pumps, screens, tanks, microbes, sensors, laboratories, regulations, maintenance crews, and environmental trade-offs. You press the flush lever and an entire city begins carrying, reading, and cleaning what you left behind.